Hi everyone, this is a Mergebase video on the Java ecosystem and how to protect it against software supply chain attacks. And just a little spoiler, Mergebase is the best tool to protect your Java code from software supply chain attacks, and there's a few reasons for that. We have dynamic application hardening, which shrinks the attack surface, which means not only are you better protected, but actually engineers have less work to do. We have the lowest false positives in the industry, and really make sure that engineers are not wasting their time. And then in addition, we really support everything in Java. So we support, for instance, all the build tools like Maven, Gradle, and Ant. We support things like Uberjars. We support the ability to detect copy and paste in Java. So even if you took a piece of a library and put it somewhere else, we can detect that. So we have a number of unique features that really help Java engineers. Okay, let's get into the conversation. So I've got with me Delan Elliott, who's a key engineer at Mergebase, and he's also a Java developer, so he can speak from experience. And so, Delan, first question: why is software composition analysis so important for Java engineers?
Well, hi, thank you for having me on here. There's a few reasons why Java focuses on SCA so much. One of the reasons is that Java has more critical vulnerabilities than all other common languages combined that you're using in the software development industry currently. So some of the reasons for that is that Java gets targeted more. It has a very large open source ecosystem. Java has been historically used in environments where security is important. So banking, government, highly regulated industries have used Java historically, in the last 20 years. So that means a couple things, which is it means widespread usage of the same libraries. So those same open source libraries are used in multiple places, which means more attack vectors. And it also means targets are high value. So attackers, they want to do the least amount of work to get the most profit. So Java has been a profitable place for attackers to look for vulnerability.
And talking about that, about profitable places, can you mention some examples of vulnerabilities that really have hurt organizations, vulnerabilities in Java libraries?
Sure. Two of the most famous ones. The first is the struts vulnerability that was found in 2017. And that was, well known to take down a branch of Equifax, which didn't upgrade their version of struts after this vulnerability was found. So it was about 6 months after the vulnerability had been published. Everything was public. There was one branch of Equifax, that left a few servers running a vulnerable version of the struts component. They were probably using struts across many different servers, and once you leave one open to one of these critical vulnerabilities, it can leave you open. Your entire organization can take $1.3 billion in damages from one single attack from one open source component.
Yeah. Now, one thing I find a little bit puzzling about Java is that Java is considered a very safe language, right? It's very strongly typed. It has dynamic memory allocation, no pointers, and things like that. So how is it then possible that it has more critical vulnerabilities than all other programming languages combined? Well, you kind of mentioned a little bit about this already, but I still find it puzzling.
Well, the biggest thing is that Java relies, almost entirely on open source development, and so even the largest organizations are not going to be writing all of their own code. So what that means is that you're going to have different levels of security research, as well as different levels of ability for those developers to have fully tested their code for every single type of vulnerability. So generally speaking, the commonly used libraries that are run by Apache and other companies are very hardened, but there's always chances for security researchers that are incentivized by being able to steal things from companies, that these attackers are incentivized to be able to find even the smallest library that might be used by many companies across the world. So as long as there is this widespread adoption of open source libraries across large corporations, you're always going to have attackers that are focusing on these products. So these attackers probably have more time to research the vulnerabilities than the developers of the actual products do. So in that environment, you're going to see more vulnerabilities pop up than other languages.
So you're essentially saying it's a function of effort. Like there's a lot of focus on Java and a lot of effort.
Yes.
I mean, what we're seeing that some other languages, I think, for instance, Elixir that Mergebase also support, there's like 5 vulnerabilities total.
Yes.
Known vulnerabilities, and this is Java is really the focal point of a lot of good and bad research. In essence, I think that's
Yes.
what you're saying. Now, what are some of the issues kind of to consider when you work with an SCA tool? Because I think it's clear you need something like this. What do you want to consider when you're selecting a tool and using it?
Yeah, so there's a few things to consider. If you're talking about the issues you're trying to avoid and mitigate, you're trying to make sure that your SCA product has good accuracy. So whether there's a couple of different types of accuracy. There's accuracy in terms of finding all of the correct components in your product, and then there's accuracy in terms of the data associated with those components. So does it have low false positive rates? So when you're working with an SCA tool, you're not actually every result is not always going to be accurate. There's going to be some erroneous results. Even in the most accurate tools on the market, there are some false results. So you're trying to look for the tool that has the most accurate results, the fewest false positives, especially because for every false positive, that's time your security team needs to go verify, triage, and then mark that result as false. So we pride ourselves on having low false positive rates because we want to save security researchers and developers time. And so that's one of the main things we're looking for. Then for Java specifically, and for some other languages, you want to make sure it supports your dependency manager, or how you manage your dependencies internally. So for Java, there's 3 main tools which are still used, which is Maven, Gradle, and Ant. And so with Mergebase, we support all those tools, and we support Ant, which is unique in the industry. Most SCA tools are not able to support binaries built with Ant, but we have advanced binary scanning capabilities. And so that's one of the things you're going to be looking for, is to make sure that your dependency manager is supported by your SCA tool.
Okay, so your tools being supported is important, and then accuracy. So I'm also hearing a lot about SBOMs, software bill of materials. So that's increasingly prevalent in the industry. And how does that relate to SCA? How does that fit into the picture?
Yeah, so most SCA products, what they're doing in order to give you a result on what's the state of your product, is we're going to index all of the components that your product contains, and we're going to give you the vulnerability information related to those components. So what software bill of materials is at the basic level is it's that index of all of those components and the versions of them. So all SCA tools are going to provide you some level of support for SBOM generally. Not everyone, but most of them now. There's a growing need for companies to generate these SBOMs, and there's a few reasons for that. If you are a software vendor, your clients may want an SBOM for your products. If you're a software consumer, you may want to get an SBOM from your vendor because you want to manage the vulnerabilities that are in this product, and keep your vendor honest about how often they've updated their components. And regulators are also demanding this for some industries. So especially healthcare recently, as well as embedded products, especially U.S. government regulators are asking software developers and vendors to provide SBOMs for all their software.
Yeah. So U.S. regulators are leading the charge here, and that makes it SBOMs a critical component of your strategy to defend against software supply chain attacks. So when I'm an engineer, when I'm a Java engineer using SCA capabilities, what are some of the capabilities that make my life easier?
Essentially, what you're doing with SCA, you are trying to find the current state of your product, as well as what changes need to be made to make the software secure if it's not currently secure. So some things that help with that is what you might call developer guidance, which is showing you exactly which versions of the software you're currently using, as well as which version you should be using to make your software secure. So that that guidance or the suggestion of a non-vulnerable version is important, as well as either automatically or manually generating code snippets that you can put into your dependency management files. So in a pom.xml, just getting a nice little tag that you can paste into your code, things like that. Another thing is with SCA, you also want to know whether you have direct or transitive dependency on vulnerable components. So with Java, especially, you're going to have many transitive dependencies in your products. If you're using Maven, lots of things get pulled in that you might not have added at all into anywhere in your software, but they actually get pulled in by other pieces of software depending on them. So insight into where is the root cause of this dependency being in your project, and then also providing insight into your code coverage if you're using this vulnerable library many times throughout the project is something that if you can do that, that's also very helpful. As well as while you're doing active development on your projects, you want to be able to use an SCA tool. But you don't want this SCA tool, if you're using it in your CI/CD pipeline, you don't want it to block this pipeline permanently. So having something like what we call our suppression management in Mergebase. So having a way to manage the risks on a security dashboard without blocking your build pipelines. That's something that's very important to interacting between your security officers and your developers, and making sure that your developers can continue to work while still improving the security of your product.
Okay, so you're mentioning developer guidance, things to transitive, things to make life easier for developers and not blocking your build pipeline. So talking a little bit more about the build pipeline, so CI/CD tools, what tools does Mergebase support for Java developers?
Yeah, so we support all the major build pipeline tools. So we have plugins for some of them, so Jenkins, Azure DevOps, Bamboo, things like that. We have built-in plugins that make your life, one click to get Mergebase working. And then we have scripts as well as example files for getting it working in many other environments like GitLab CI, GitHub Actions. I think those are probably all the main ones. TeamCity, basically every CI/CD pipeline Mergebase will work with, and it's relatively simple. And it's about 3 lines in your script in order to add Mergebase into your CI/CD pipeline. And we have many command line options that make it possible to block or not block the build depending on the results. And we give you lots of flexibility on how to use Mergebase within the CI/CD environment.
Perhaps now that we're on it, mention some additional benefits that Mergebase has for Java.
Sure. So there's 3 main things I want to talk about, which is first that Mergebase, we protect all of your IP. We actually don't upload any code. No code files are uploaded to Mergebase servers, so this can be very important for some organizations that want to maintain code integrity. The only thing that we touch is your pom.xml type files, so any dependency management files. So basically the things that we need in order to index the exact versions of components that you're open source components that you're using. Those are the only things that we upload. We don't upload any code. We also have the ability to intercept supply chain attacks. This is because we have a fingerprint, a binary fingerprint of every single component in the Maven ecosystem. And so if you're using something like Artifactory or some other internal repository tool, we are able to make sure that isn't being compromised by an external actor. So because we have basically a verification process for all of these binary artifacts. So if you're doing a binary scan of any of your jar files, we can protect against supply chain attacks. Another feature that we have specifically for Java is we have dynamic application hardening. And this is a unique feature to Mergebase that no other SCA offers, which allows us to shrink the application's attack surface by monitoring what parts of a library are used and being able to shut off all the parts that aren't used during the normal operation of the product. So, by being able to do that, we reduce attack vectors for malicious actors, as well as provide more peace of mind with your open source components.
Yeah, that last point, dynamic application hardening, where you shrink the attack surface. I always get the question, well, how does that work? How is that possible? Can you say a little bit more about dynamic application hardening?
Sure. Well, we don't want to get too technical, but essentially, Mergebase has a patented technology where we're able to do a very small rewrite to the content of your jar files, which allows Mergebase to essentially monitor the usage of all the methods within your application. And so we have, as well, we have analysis of, which methods are used in attack vectors for vulnerabilities. So for critical vulnerabilities, we're able to monitor the method usage, and then ensure that those the critical vulnerability methods aren't being used, or they're being used in the null pattern. So, and the first thing people usually ask about this is what's the performance impact of something like this? And Mergebase actually has this dynamic application hardening has a very low performance impact. It's 1%, so maybe something like that, generally speaking. And so, it's not the same as running something like a runtime agent where you're doing live intercepts of all calls, or memory interception, things like that, which can have, 5-10% performance impact, even more in some cases. So, Mergebase has a very low footprint for using dynamic application hardening.
Yeah, well, to wrap up, how can I learn more about SCA and about Mergebase?
You can go to our website, mergebase.com. We have lots more information there about the product, as well as specifically about our use in Java. And you can go to mergebase.com/pricing to find out more. We're very open about our pricing model. You'll find most organizations, we have a plan suited for you. So please head there.
Well, thank you very much, Delan. It's great to hear kind of your deep insight into the Java ecosystem and how to protect it, especially with Mergebase.